Look at the Earth and the Moon, how they rotate without a seeming care in the world. But there is an intruder that is about to enter their space. Apophis, the asteroid, is going and heading on a collision course with the Earth. But what can we do to stop this? Luckily, NASA has done a report on what we can do to keep asteroids from impacting the Earth. And there's a couple of things that they have proposed. The first one is that we simply have a gravity tractor, which I will represent by this lonely teapot. This teapot is rotating around, but a true gravity tractor will stay in the same space by use of some sort of ion engine or something like that to stay there. And instead of weighing 500 grams, it'll weigh maybe 5 kilograms. So that is option one, and this is a good option if we can manage to make it work. Option two, if we need a little bit more energy, we don't have quite as much time, that we can do is we can take this teapot, and instead of having it rotate around, we can have it smack into the asteroid and hope that it diverts it. Now, this has its own issues. The biggest issue with this kind of approach is that it might actually destroy the asteroid and break it into lots of fragments, and these fragments could still cause considerable damage if you have a large enough asteroid. So we have to be wary with this approach, and we suspect that asteroids are not this collective single body as we see here, but rather they are more likely to be a collection of boulders and rocks. It's very loosely put together. Then the third idea, it looks like we impacted Earth there, so that would be a very bad day. But the third idea they propose is instead of using just an impactor, why don't we use a nuclear weapon? Now, this is the favorite idea of Hollywood because nuclear weapons seem to be able to do magic. But this has some similar risks that it could possibly do more damage than it's worth. But it will probably add more energy and thus can be considered. Now, there is a fourth option that NASA did not include in the report that they indicated. So I will put Apophis back in, and we'll zoom on us. Apophis is, of course, a real asteroid that is going to approach Earth in 2029 and again in 2036. Both times it'll be very close. And in 2036, it actually had the largest chance of impact of any major asteroid that we have observed. Okay, so the third option for asteroids, we take, and instead of trying to do something really fancy, we change the color. And let's make this bright. So we somehow have some sort of paint that would have to work in a vacuum and in zero gravity that we lighten the entire asteroid or one portion of it. Now, what will this do? Being brighter, and it will probably be brighter because most asteroids are pretty dim, the sunlight will push more on it. And the sunlight pushing more on it will nudge it gently out of its course. And most of the time, an asteroid impact is extremely precise, especially if it has to pass through a gravitational body such as Earth first. The Apophis window for it to impact Earth in the 2030s is only 1 kilometer wide. It has to pass through in order to do that. So if you can shift it just a little bit, then it can do that. And sunlight will push an object gradually. The second effect it does is it will tend to change the temperature of the asteroid. Now, the asteroid, as it rotates around, cue rotation. As the asteroid's rotating around, the side that is facing mostly towards the sun will become a little bit warmer. And that will slowly shift here. And at nighttime, this side will be warmer than the daytime. If you go outside on Earth at sunset, it is almost always warmer than it is at sunrise. And the same thing applies to an asteroid. Now, how does that make a difference in the orbit? Well, the heat will produce more energy in terms of photons. And this will tend to push, the warmer side will tend to push more than the colder side. And so there will be a gentle pushing motion that will be kind of from this direction, from the warmest part of the asteroid towards the cooler part. And that is called the Yarkovsky effect. And it can also change the position of asteroids. It's been known to push it as much as 26 kilometers, I believe, that it's been measured. Now, all of these methods work best for small asteroids, especially if we have a lot of time to do them. But hopefully we can keep on tracking them well enough to maintain this. Anyways, thanks for joining me. Let me know whatever questions or comments you guys have. And this is Ben Pearson, the Roadster Tracker. Until next time.